All right, we've multiplied fractions, we've added fractions. So today we're going to look at the first part of adding and subtracting, which in order to add or subtract fractions, first thing you have to do is find a common denominator. So the first thing, we kind of look at proportions. If we were going from 3 to 35, or 7 to 35, what do we have to do? Times by 5. That's a very basic fraction. Obviously, we have passed the basic fraction, so we're going to have fractions with variables. So let's say our common denominator between the two would be 18a squared. What would we have to do to 3a to get 6a? One thing you could always do to figure this out, you could go ahead and just write it as a division problem. So what is 18 divided by 3? 6. So we're going to multiply by 6. A squared over a would give us a to the first, or just a. So we're multiplying 6a. So we should erase this part. 8 times 6 is 48. We have our times a, 48a. So our answer in this part would be 48a. Let's see if there's another one of that nature. So same sort of thing here. Let's make that a third. We have 5 over 8n, and then our common denominator is going to be 16n to the third. What do we have to multiply 8 by? 2. N needs 2 more n's, so it will be n squared. So now 5 times 2 is 10, n squared. All right. So those are our basic. All right. So where we're going to go eventually is where we have one like this. Remember, they don't have it written. They have a binomial just sitting there, but if we have a binomial number, I like to put them in parentheses just so you know it's one term. This part, these two are the same. What does this expression need in order to look exactly like this expression? So we need to multiply this by x plus 1. If you multiply the bottom by x plus 1, you multiply the top by x plus 1 as well. So on the top, we would now have 2 times x plus 1, or you could write it as 2x plus 2. So you have to figure out what makes them exactly the same. Let's do another like that one. So we have 4 over x plus 3, and our common denominator is going to be x minus 2 and x plus 3. So what does this first denominator need to look exactly like the second one? So we need x minus 2. So now let's go ahead and distribute it, because that's how we want our final product to be. The final answer is 4x minus 8 over x minus 2x plus 3. Okay. We're not simplifying them, because what we're doing eventually is we're going to take two things with the common denominator and combine the tops. So that's why we do want to go ahead and multiply out that first step. All right. Erase the whole thing. Now we're going to give you two fractions. And we want to figure out what the least common denominator is going to be. So let's just say there's an and in there. First thing we need to do in order to find least common denominator is simplify down our denominators. What's common in these two things? 4, 6. So there's our 5. Now what's common in these two? 9. So nice thing is, notice those are the same. That's good, isn't it? So our least common denominator probably has to have x minus 5, but now we need to use these two numbers. what would the least common denominator be between 6 and 9? Denominator, not factor. Least common multiple. 18. They'll both go into 18. Kelly, if we had this problem, we would have to get 18 as our denominator. So we get so on and so forth. Okay. So our least common denominator would be 18 over x minus 5. Okay. Let's do one more like that, and then we'll show how to finish it out with the fractions. Okay. Okay, so we have 2 over 3a minus b and 5 over 6a minus 2b. So on this first one, is there anything common? 1, so we can just leave it 3a minus b. Anything common on these two? 2, which leaves us 3a minus 2b. And that's perfect. So our common denominator, we know we've got 3a minus b, but what else is over in this one? 2. So they both need a 2. Okay. So now let's look at it. We're going to change our numerators as well. Yes, John. Yeah, that's what I looked at. Thank you. Yes, you're right. 3a minus b. So now let's look at this is the same. So do we need to change? We did not change the denominator, so do we change the numerator? We multiply by 1, basically. But over here, what did we multiply this denominator by? We multiplied by 2. So our two new fractions would be 4 over 2 times 3a minus b and 5 over 2 times 3. And then if we, next week, we could look at adding them. Obviously, this would be 9. That's a next week part. Okay. So, all right, let's do a couple more of that nature, because those are when it gets most difficult. This one is probably one of the hardest of today's lesson. Okay, so these are our 3 fractions. These two are already simplified, yes or no? Okay. Can we break this one down?
Yeah.
The difference of 2 squares. So we get y minus 1, y plus 1. All right, so this is basically now. What does this need in order to look like this one? So this one needs y minus 1. And then we get, okay, what does this one need in order to look like this? Y plus 1. Okay. So now let's rewrite them as 3 fractions. This one's already y minus 1, y plus 1. So we just bring down our 4. This one, we said multiply by y minus 1. So we get 3y minus 3. This one, we said multiply by 7y for y plus 1, so it's 7y plus 7. So these would be our 3 new fractions, and then we could either add or subtract or go on from there. All right. So what I want to do, excuse me, page 261, 262. Nine to 31 odd. 261, 262, 9 to 31 odd.